Yes, a World War II rifle grenade could punch through more than 100 millimeters of armor from a standard infantry rifle. Wartime German trials recorded penetration as high as 126 millimeters. The warhead worked. Hitting the tank was the inconvenient part. Here is every major type, how it worked, and which ones actually mattered in combat. First, we have the M9 anti-tank rifle grenade, built around an acorn-shaped hollow charge warhead and a fin stabilizer tube that fitted over the rifle launcher. It measured 11.24 inches long, weighed 1.23 pounds, and carried 4 ounces of trinitrotoluene. Its point-detonating fuse was less sensitive than the later M9A1, so a poor or glancing impact could prevent proper functioning. It gave an ordinary rifleman an anti-armor weapon, provided the armor approached from a convenient direction. Next, we have the M9A1, which replaced the acorn-shaped head with a two-piece cylindrical body and a more sensitive impact fuse. The M3 grenade cartridge launched it at roughly 165 feet per second, measured 5 feet from the muzzle. The shaped charge needed to strike within roughly 20 degrees of a square impact, and the manual warned of danger for 50 yards behind the grenade. It was a genuine squad-level anti-tank weapon, but accuracy and impact angle mattered as much as the explosive itself. Let us continue with the M17 fragmentation rifle grenade, which placed a fragmentation body similar to the Mark II hand grenade over an impact fuse and finned tail. It weighed approximately 1.47 pounds and contained 0.77 ounces of explosive powder. Its fuse worked against firm surfaces, but could fail when the grenade struck water, mud, or soft sand. Hard ground cooperated. Much of the Pacific did not. Moving on to the Mark II grenade with the M1 projection adapter, an economical system that converted a standard hand grenade into a fin-stabilized rifle grenade. The original M1 adapter had 4 spring steel prongs, no supporting base cup, and was intended specifically for the Mark II fragmentation grenade. A retaining piece held the safety lever during loading, then setback released it after firing and started the grenade's roughly 4.5-second delay. It was not elegant, but it turned existing grenades into ranged explosives without asking the supply system to invent another war. We have the M19 white phosphorus smoke rifle grenade, which used an impact fuse and internal burster to split its casing open. The grenade weighed approximately 1.57 pounds and scattered burning white phosphorus across an area of roughly 25 square yards. Grimly, the phosphorus generated dense white smoke, ignited combustible material, and could cause severe casualties among exposed troops. It was officially called a smoke grenade, but anyone standing inside the cloud received a more complete explanation. Next, we have the M20, filled with 10.8 ounces of hexachloroethylene smoke mixture. Its impact fuse ignited the filling, which burned for approximately 1 minute and forced dense white smoke through openings in the grenade's base. Unlike the M19, the M20 was intended exclusively for screening rather than incendiary or anti-personnel work. It made a wall of smoke, not a miracle, but sometimes a wall was enough.
Let us continue with the M22 colored smoke rifle grenade, designed primarily for battlefield signaling. It was issued with red, green, violet, or yellow smoke fillings and measured 10.72 inches long. After impact, the smoke composition burned for approximately 1 to 1.5 minutes through emission holes near the base. It allowed infantry to mark positions, targets, and landing areas when radios were unavailable or simply behaving like wartime radios. Moving on to Britain, we have the number 36M Mark I Mills rifle grenade, a standard Mills grenade adapted for cup discharge. A 2.5-inch gas check disc screwed into its base, while rifle use normally required a 7-second igniter instead of the shorter hand grenade delay. The grenade weighed about 1.5 pounds, but later wartime reporting stated that it was no longer being used regularly in the rifle role. The capability remained real, the enthusiasm had moved elsewhere. Next, we have the number 68 anti-tank rifle grenade, a fin-stabilized shaped charge weapon fired from the British 2.5-inch cup discharger. Its bell-shaped steel body weighed approximately 1.95 pounds and contained 5.5 ounces of explosive around a hollow metal cone. Wartime manuals gave it an effective range of roughly 50 to 76 yards. It offered British infantry portable anti-armor firepower, but only at distances where the tank crew might begin taking the matter personally. Let us continue with the number 85, a late British design based closely on the American M9A1. Its number 430 impact fuse was designed to function at impact angles as steep as 45 degrees from the ideal line of impact. British testing took place during 1944, and formal adoption came in April 1945, leaving its World War II service extremely limited. It was a respectable solution that arrived as the appointment was ending. We have the Gewehr-Sprenggranate, Germany's standard fragmentation grenade for the rifled Schiessbecher cup launcher. It weighed approximately 9 ounces, contained about 1.1 ounces of explosive, and could be fired to a maximum distance of roughly 250 yards. The fuse detonated on impact, or destroyed the grenade after approximately 11 seconds if it missed. Its base could also be removed to expose a 4.5-second hand grenade igniter, because German ordnance occasionally believed one complicated object should perform several jobs. Next, we have the Gewehr-Panzergranate, the first standard small anti-tank round for the 30mm Schiessbecher cup launcher. It measured around 6.4 inches long, weighed 8.8 ounces, and carried approximately 1.75 ounces of explosive. Its shaped charge warhead was intended for direct fire at armored targets within roughly 100 yards. It gave British infantry portable anti-armor firepower, but only at distances where the tank crew might begin taking the matter personally. Moving on to the Grossgewehr-Panzergranate, a larger shaped charge round developed for the same rifled cup system. It weighed approximately 12.75 ounces and carried about 4.25 ounces of explosive, more than twice the charge of the smaller version. Its useful anti-tank range remained around 100 yards because a larger warhead did not make the rifle or its shooter any steadier. The larger charge improved armor effect without requiring an entirely new infantry weapon. Let us continue with the GG-GAP P40, an early fin-stabilized anti-tank grenade fired from a dedicated spigot rather than the later rifled Schiessbecher. It used 6 tail fins, a wooden bullet launching cartridge, and a streamlined warhead measuring approximately 9.3 inches long and 2.4 inches across. The complete grenade weighed approximately 515 grams, and its dedicated sight covered ranges out to approximately 100 meters. It was portable and technically ambitious. Accuracy was less inspired. We have the Propaganda Gewehrgranate, a steel leaflet container launched from the standard German rifle grenade cup. It measured roughly 5.5 inches long, weighed approximately 8 ounces when filled, and could reach around 500 yards. A delayed internal charge opened the casing in flight and scattered the propaganda material over the target area. Shipping containers held 40 grenades and 41 cartridges, providing one spare round for a marketing campaign with unusually poor audience engagement. Next, we have the SS Gewehr-Panzergranate 46, a late-war anti-tank design with a 46mm warhead mounted over a stem that fitted the 30mm cup. It weighed approximately 15.5 ounces and carried about 4.8 ounces of a cyclonite and trinitrotoluene explosive mixture. German testing recorded penetration approaching 90 millimeters of homogeneous armor under favorable conditions. Let us continue with the SS Gewehr-Panzergranate 61, which expanded the same concept around a 61mm shaped charge head. The grenade weighed approximately 19 ounces and contained about 8.5 ounces of explosive. Trials credited it with maximum penetration of roughly 126 millimeters of homogeneous armor, although a quarter-inch spaced plate positioned 11 inches ahead of the main armor could defeat the charge. Armor designers called that useful test information. The Grenadier called it a very poor afternoon. Moving on to the Gewehr Fallschirm Luftgranate, an illuminating grenade that carried a burning star beneath a small parachute. It weighed approximately 9.9 ounces and measured 6.88 inches long. The first delay operated about 6.5 seconds after firing, followed roughly 2 seconds later by the ejection of the parachute and illuminating star. Its purpose was not destruction, but temporary battlefield visibility, target location, and signaling during darkness. We have the Dyakonov Fragmentation rifle grenade, built with a hollow central tube that allowed a normal 7.62 by 54 mm R bullet to pass directly through it. The grenade was approximately 40.8 millimeters in diameter, weighed around 360 grams, and contained about 50 grams of explosive. Its body could produce several hundred fragments, giving the rifleman a small area weapon rather than a precise point-target projectile. The bullet-through system removed the need for a special blank cartridge, which was its clearest logistical advantage. Next, we have the VPGS-41, a long rod-type anti-tank grenade inserted directly into the muzzle of the Mosin rifle. It measured approximately 455 millimeters, weighed about 678 grams, and carried roughly 334 grams of pressed trinitrotoluene. It was adopted on the 13th of October, 1941, but production ended during the spring of 1942 after accidents and reliability problems. It was an emergency weapon designed during an emergency, and it behaved with appropriate confidence. Let us continue with the VKG-40, a more conventional shaped charge grenade fired from a cup fitted to the Model 1891-30 rifle. It weighed approximately 220 grams, carried about 90 grams of explosive, and required a dedicated 7.62 millimeter blank cartridge. The official manual gave an aimed range of 150 meters, a rate of 5 to 6 rounds per minute, and penetration against armor up to approximately 50 millimeters. It was a far more practical design than the VPGS-41, although by late war standards, 50 millimeters of armor was not an especially ambitious opponent. Moving on to Japan, we have the Type 91, a multi-purpose grenade designed for hand-throwing, knee mortar use, or rifle launching. In rifle configuration, a finned tail assembly accepted a special 6.5 millimeter cartridge containing a wooden bullet. The grenade weighed approximately 18 ounces, contained around 65 grams of powdered trinitrotoluene, and used a delay of roughly 7 to 8 seconds. One grenade for 3 launching methods made logistics happy. The long delay gave everyone else time to reconsider their position. We have the Type 99 rifle grenade, essentially the smooth-bodied Type 99 hand grenade launched from the Type 100 discharger. Unlike many rifle grenade systems, the launcher used standard ball ammunition, with the bullet caught inside the discharger while the gas propelled the grenade. Effective range was approximately 100 yards, and the grenade's time fuse burned for roughly 4 to 5 seconds. Standard ammunition simplified supply, while adding one more mechanical event directly in front of the rifle's muzzle. Next, we have the Type 2 30mm hollow charge rifle grenade, a compact, dedicated anti-armor projectile with a finned tail and impact fuse. It measured approximately 159 millimeters long, weighed 231 grams, and carried 49 grams of a 50-50 cyclonite and trinitrotoluene mixture. Its fuse and basic internal arrangement followed the same pattern as the larger Type II 40mm grenade. It was easier to carry, although the smaller warhead contained less than half the explosive of the 40mm model.
Let us continue with the Type II 40mm hollow charge rifle grenade, a Japanese design closely based on Germany's large anti-tank rifle grenade. It measured approximately 203 millimeters, weighed 349 grams, and contained about 107 grams of cyclonite and trinitrotoluene. It was launched with a special wooden bullet cartridge, and testing recorded penetration of roughly 3 7/8 inches of mild steel. That was serious performance from a rifle muzzle, followed by equally serious recoil at the other end. Moving on to the Type III Modification 1, a purpose-built high-explosive grenade with a smooth cast steel body and 4 stabilizing fins. Its tail fitted a spigot launcher attached to either the Type 38 or Type 99 rifle and was propelled by a special wooden bullet cartridge. An instantaneous impact fuse used a shear wire safety system and initiated a cast trinitrotoluene main charge through a primer, relay, and booster train. Unlike the Type 91 and Type 99, this was designed from the beginning as a rifle grenade rather than a hand grenade given additional employment. We have the Japanese smoke rifle grenade, launched from a special adapter fitted to a 6.5mm rifle. It measured approximately 8.5 inches long, weighed 1.29 pounds, and contained roughly 0.6 pounds of smoke mixture. Its cartridge used a wooden projectile to generate launching pressure without sending a normal bullet into the grenade. The resulting smoke could screen movement or mark a position, which was considerably more useful than merely making the battlefield difficult to photograph. Next, we have the Japanese small incendiary rifle grenade, a white phosphorus projectile fitted with a finned spigot tail. It measured approximately 254 millimeters long, had a maximum diameter of 48 millimeters, and weighed about 0.46 kilograms. It used the Type 97 fuse and could be launched from Type 38 or Type 99 rifles with a wooden bullet cartridge. Its burning phosphorus provided smoke and incendiary effect against exposed supplies, buildings, vegetation, and personnel. Finally, we have the Vivan-Bissier's rifle grenade, better known as the VB, which used a central tunnel that allowed an ordinary service bullet to pass through the grenade. The United States Marine Corps' 1940 Small Wars Manual listed a 17-ounce Mark I grenade with a range of roughly 120 to 180 yards and an effective bursting radius of about 20 yards. France still retained the system in 1940, while the Marine Corps manual noted that the 60mm mortar had already replaced it as the Organic Rifle Company grenade weapon. It was a clever First World War design that entered World War II mainly by refusing to leave the inventory. The pattern is clear. Fragmentation, smoke, and signaling grenades remained useful, while anti-tank models became larger and more powerful as armor improved. The shaped charge gave an infantry rifle surprising power, but range, accuracy, fusing, and impact angle remained severe limitations. By 1945, the warhead became genuinely dangerous to tanks. The delivery system was still a rifle, a blank cartridge, and somebody's shoulder.